I've been lately developing an MCP server, and there is an interesting thing I want to talk in this video. So as you can see here, this is more or less the general architecture of the MCP protocol, clients and servers. So you have clients, in this case the reference ones is Cloud Desktop. Then developers can build servers that can interact with the client via the MCP protocol, which is open, and ideally it will be implemented by other reference LLMs. So you could build ideally an MCP server that could interact with many different clients, okay? And servers can communicate with either local resources, for instance, if you want to communicate with a local file system or a local database, or with remote resources in the case of connect to GitHub, to Google Drive, or in our case, we built a server that communicates with a Tinybird workspace. The interesting part about this is even when we are talking about client and server, everything is actually running on your computer or in your user's computer, in the case you are an MCP server developer, as me. So this presents a problem or a situation you have to solve, which is, how do I know how is behaving my MCP server? I want to be able to maybe debug logging, maybe get some product metrics, etc. So I've prepared here a small graphic representation of the problem. So we have here, in this case, Cloud, which is an MCP client and an MCP server I've built. As I've said, this is running locally. So me as a developer, I don't have access to the user logs. I don't know what's happening with my server. I don't know even if anyone is using it. And I also need a way to debug logging in case there are errors or whatever. And ideally, having the chance to do some analytics to know what are, for instance, the more used tools in my server or the ones that work worse, okay? So when you start thinking about this is, okay, I just want to develop a server. This is what I want, but I have a new problem, which is I need to take care of logging, metrics, monitoring, user events. So the puzzle starts to complicate, okay? So there are two ways to handle this problem. I've divided into the infra path, or the how would solve this a platform team, and how would solve this development team, okay? So if I was working for a platform team, I would probably have some product for logging analytics, some other for metrics, some other for monitoring. I've put here some examples, but there are many, many more. And this presents several problems, which is, in the end, you need a team that is able to operate all that platform stuff. And it has several challenges, like usually it's hard to set up everything. It's hard to scale it. At the beginning it might work pretty well, but in the end, at some point you have to work on scale each of the components. Of course, you have some heavy maintenance to do, keep up with the latest versions and so on. And there is also something that it might not look a problem, but most of these tools are actually specialized on a very specific thing. For instance, Loki is very good. It's real good on logs analysis, stats on metrics monitoring, etc., etc. So you need a deep knowledge on how everything works, not only from the point of view of the operation, but also from the point of view of the user. As a developer, I'm a user of some of those tools, and I have to learn how to extract what I need from them, okay? And there's another path, which is the interesting one, which is, okay, I'm a developer, I'm in the mood of building a product, in this case a server, and I want a simpler approach, okay? So in this case, we can have a unified way to bring all that I mentioned, logs, metrics, monitoring, user events, to one single place, which is Tinybird, with a simplified flow, okay? The nice thing about this is it's just me. I'm just a developer, and I can manage a Tinybird account, and I can bring data, and I can analyze it, and I can work with it to improve my server. So there are several advantages of this. I don't have to take care of any infrastructure. Tinybird is self-service. I don't have to worry about scale. I can send any throughput, and I would get back a low latency when I request for data. And I can focus on building. I don't have to worry about anything else. So this is what I'm going to explain right now. So I have my MCP server. It's running locally in the computers of my users. I'm going to send logs and some other events to Tinybird. And from there, I'm going to do log analytics, monitoring, and ideally I could do user events analytics. I'm not doing it in this case. And I still can use my favorite tools. I love Grafana. I love Prometheus for metrics monitoring. I could build custom APIs. I don't have to stick to any specific tool. And I can be more straight from my ideas to implementation, to gather metrics, and to improve my server. So what we've built related to this is this. So this is a repository where we have our MCP server. You have another video talking about it. And here we have a folder in which we have a Tinybird project to collect logs from my server and provide some analytics metrics, together with some Grafana sample dashboard and instructions on how to build it, okay? So it's pretty simple. It's just 3 steps. So the first step is deploy this project into a Tinybird workspace. So there's a button in here which redirects to Tinybird. You can sign up, you can create a new workspace. I'm going to create a new one, but I will use one I have already created. Test 011. So after a few seconds, what I have here is a set of data sources where I can collect my logs and transform them, and a set of APIs that return what I consider are the metrics I need to evaluate for my server, okay? So let's take a look at the data flow. Well, I'm going to go to the actual project, this one. And let's see the structure of the project. So basically we have 2 entry points. We have a data source to collect logs from the MCP Python SDK, and another one for the TypeScript SDK. The reason is for the Python SDK, I'm using the standard logging library, and it has like a kind of an unstructured field with some of these columns. For instance, what is the app name of the server that is sending the logs, timestamp, the message I'm logging, what is the file that is logging its trace, the function, the log level, etc. Okay. And for the case of the logs from TypeScript, it's more structured. So you basically have a timestamp, a unique session ID you can build on your server, the log level, and the rest of the record you can log from the application. Okay, I'm going to focus on the Python one. Since we have two different entry points, in this case I've built a couple of transformations just to take the columns I'm more interested in to build metrics. So I want to collect the name of the application of the server. In my case, I've called it MCP Tinybird. A timestamp for each log. What is the function that is sending the log? What is the tool? And this is specific for this implementation. I want to know what are the most used tools in my server, what are the ones that error more, etc. Same for prompts and same for resources. Okay, remember these are the three components of an MCP server. So in my server I provide tools, I provide prompts, and I provide resources. Then the log level to know if there is an error or not. A unique session ID I'm building from my server. The version of the server deploy, because since this is installed locally in users' computers, there might be different versions working at the same time for different users. And this is the message I'm logging, okay? So taking as the base this data source, then I can do APIs that do analytics on them. And it's pretty simple what I've built. So basically I want to count errors by tool. This is pretty simple. I group by hour, by the name of application, by the version, and by the tool, and I count errors. Then I want to count usage in general without filtering by error. And then I want to get unique sessions. I want to know how many different sessions, how many chats have my users open while using my server. This is like a usage metric, okay? And with that, we basically have aggregated statistics for date, application, version, and tool. These are the dimensions I'm going to be able to filter. And then we have the metric. And for this specific case, I'm going to extract two different kinds of metrics. Total metrics, since I released my server until now, these are total counters, and metrics for the last 5 minutes, okay? And all these metrics, I'm going to collect them in a single API in Tinybird that I'm going to publish as Prometheus format. So in this way, I can use, in this case, Grafana and Prometheus because it is the tool I like to use to monitor and for alerting. I gather all the metrics in Tinybird and I publish them as an HTTP API in the Prometheus format, okay? And apart from that, I also want to do logs debugging. So I've built another API endpoint which just returns raw logs, okay, from the source table with different filters. I can filter by date, I can filter by app name, by version, and I can filter by message, okay? So let's move on. Now, okay, I have the project. This was just an explanation. It was just one click to deploy. And I have to feed this project with my logs and events from my MCP server, okay? So as you know, there are two different kinds of SDKs for MCP. There is the Python SDK and the TypeScript one. In the case of the Python SDK, we are providing a library which provides a handler for the standard login library. So what you have to do is you go to the project you created, get a write token. This token has write permissions on the data sources that collect the logs from the application. And you take also the API URL. Okay, you can grab it from here and the token from here. So once you have those two credentials, you can put it on a environment variable in your server or wherever. And then you create a new Tinybird login handler. And you tell, okay, send events to this URL with this token and this data source name, okay, MCP logs Python. Remember that MCP logs Python was the landing data source, okay, of our project. This is one. So you're gonna send, your application is here in the left, and it's gonna send through HTTP events, log events to this data source. And that's it. This is all the configuration you need. Once you do this, you use the logger, your logger instance as you would use in your Python application regularly. You send the message, and additionally, you can pass an extra dictionary. This extra dictionary is going to contain the specific information for this MCP server. Since we want to filter to get metrics by session, by tool, and by version, we send in the dictionary that kind of information for each log. Let me show you an example, okay? So this is my server.py. I've created here the handler, and if I go, for instance, to the handle called tool method, okay, this is an MCP server method we've implemented with a number of tools to connect to Tinybird, okay? So each time this method is called, we send a log to Tinybird. We just use the standard Python login library. We said, okay, this is a call to handle call tool with the name of the tool, and we provide it in the extra dictionary. So when this is processed in Tinybird, it's processed by this materialized view, and we get the extra tool column, and we save it, to the tool column in here. Okay, so that's the way to send logs from the Python server, the Python application, to Tinybird. Same for errors. For instance, in this function, I have a try except. So if there is any error while processing any of the tools, same thing. We call logger.error with a message, in this case providing the exception, and we add the extra information, okay, with the tool, with the version, etc. And we can do the same in any place of the server. So whenever you use the logger, an event will be sent to Tinybird. So once you have the data in Tinybird, let me show you here. For instance, we have the API count errors. This is collecting data. This is transformating, and we have some data we can expose to, this case, to Prometheus, okay, as I mentioned before. So how we do connect this to Prometheus and then to Grafana? In the standard way you would do it with any other Prometheus HTTP compatible endpoint. So let me go to the repository again. Where is it? Here. So you very likely have a Prometheus YAML file, and you configure it to connect to your Tinybird API URL. You can take it from here. Then you put the metrics path, which is the path of our API Prometheus, which is this one from here. You have the API, v0 pipes API Prometheus. And finally, well, choosing the Prometheus format, of course, because you can export data in different formats. So this is Prometheus format. And then you provide a read token from Tinybird. In this case, it's automatically generated. Okay, we have a read token called Prometheus with read permissions on the API Prometheus pipe. Okay, and this is already working. Okay, I've already connected, and as you can see, it's being polled every few seconds, every 15 seconds. Okay, the endpoint is really fast. It's 80 milliseconds. I don't have many logs yet, but in any case, it's working against materialized data, so it's going to be always fast. And that's it. So I have this configured. Let me show you Prometheus. Okay, you put in here your token, and that's it. Every 15 seconds, it's scraping. Now, once you have that, you can go to Grafana. Let's go to Grafana. And you have some metrics in there. All of them start by MCP. So we have the total number of errors in the last 5 minutes, requests, same thing, unique total sessions, same thing. And these are other metrics, internal metrics from Prometheus. So in the same repository, there is a sample dashboard. Okay, you can find it here above. These JSON files correspond to exported Grafana dashboard. So when you import these, if you don't have a Prometheus data source and an Infinity one, because I'm using both, I will tell you why I use the Infinity one, you have to create them. Okay, they are very simple to create. Let me show you how they work. So the Prometheus one is just simple. You just have to point to where is your Prometheus server, and that's it for the basic implementation, for the basic one. Okay. And the Infinity plugin allows to connect Grafana with HTTP APIs that provide JSON data. In this case, we're going to connect it to the API logs API endpoint, so we can explore the raw logs. So we can have metrics in Prometheus, and we can have raw logs with Infinity plugin. And to configure it, you have to add the token. Again, you take it from the token list, this one, which has read permissions for the API logs, and then you add a whitelist host, which is the host corresponding to your Tinybird region. Okay, taken from here. So once you have the data sources created, you just import the dashboard. You go here, import, and you import the one we provide in the repository, and that's it. And what you get is this dashboard. Let me show you how it works. So this dashboard has 1, 2, 3, and 4 variables, which correspond, the first 3 correspond to the dimensions of the metrics we are providing. The dimensions for our MCP server is the name of the server, the versions, I have published 3, and the tools. Okay, I have a number of tools in my server and I want to monitor them. And then we have a log variable to filter the log messages. We'll see in a few minutes. And then we have panels to understand how our server is behaving. Okay, so for instance, I'm going to remove all filters and I can see here the total number of sessions by each different version. Okay, how this works? This is getting a metric from Prometheus. We have the unique total sessions, which is provided by an API in Tinybird. We build a simple metric and we add filters. Okay, since we have variables, we use variables to filter them. So anytime we filter in a variable in the dashboard, this metric is going to be filtered. For instance, this other one, which is a time series, same thing. We have a metric for the total requests by application, version, and tool. Same thing as before. We select the metric and we apply the filters, including the variable name. And same with the rest. So with this view, you can monitor how the different versions of your MCP server is working, the number of requests, the last minutes, the total number of requests, the number of errors, etc. And you can focus on specific tools. For instance, the one I'm more interested in is this one, which is the one that allows users of my MCP server to send queries to Tinybird to explore some data. So I want to know how much is being used and if it's having errors or not. Okay, some of this data is being mocked because I'm now debugging all the thing. But for instance, this one is having some errors. So I could then use the Logging Explorer. So for the Logging Explorer, this is using the Infinity plugin. As you can see, here is using the Infinity plugin I created before. And it works against the API logs API, okay, which was this one I built here, which basically returns raw logs with some filters. And same thing. Let me see where I did included. Okay, in here. Okay, and the parameters. I want to filter by the date filter I choose in the dashboard, the application name I select in here, the version, and in this case I don't care about the tool, but the log I introduce here. So I can pass all these variables as parameters to the API logs because I have it parameterized. So I have this and this parameter, app name, version, tool, and log. And if you look at the names of the parameters in the Infinity plugin, date from, date to, app name, version, and log. Okay. So that's pretty much it. Actually, I think I could add the tool. I'm going to add it. And let's go back. So if I now filter by error, I can see the errors in this time period. Okay. So I could filter out also by any arbitrary text in the message. For instance, this one. Okay. So this is a way to have a clear view of how your MCP server, which is running in the local computer of the users is behaving. So you have some product metrics, some error monitoring, and you can go down to actual logs and see what is failing and what's not. And of course, this is still Grafana. So if you wanted to add, I don't know, some alert when there is a spike in the rate of errors, you could do it. Okay, you can build a regular alerts and then add a monitor to check for them every, I don't know, every minute or every 5 minutes, and send you a message in Slack or via email or whatever. Okay, so this is it. As you can see, we've gone the developer path. We've bringing everything, logs, events, to Tinybird, and we've been able to easily publish them, in this case as Prometheus endpoint, and integrate with Grafana.